Assalamualaikum warahmatullahi wabarakatuh and good morning.
Salam.
Waalaikumsalam.
Can you see my screen?
Yes, sir.
Yes, sir.
Alright, just to remind you guys, we have midterm test on Monday, 15 November, 8 p.m. until 10 p.m. 2 hours. This is during night, Malaysia time. Okay, Monday. Alright, so we are going to continue with chapter 4. Decision logic structure. Okay, so these are the content of this chapter. Okay, we are going to look at the ini. Okay, first we are going to look at the general structure of the algorithm involving if, then, else. This is the algorithms, and then we are going to look at the types of if statement. There are 3 types of if statement. If algorithm, okay, and then we are going to look at case logic structure. Case logic structure. Okay, it is not if then else statement. Case logic structure is another way to write down the decision logic structure. Okay, and then we are going to have a look at the flowchart as well. Okay, and lastly we are going to have a look at one problem, and the solution is going to start with the PSC, IC, IPO and everything up until the dash checking. So as you can see over here, we are using the same tools that we use during the sequential logic structure. PSC, IC, IPO, algorithm, dash checking. Okay, this is applicable to all types of algorithm. Alright, so that one is part 1. We are going to cover part 1 today. Part 2 is going to be next week. Okay, this is another thing. So once you are familiar with the basic of if, then, else instruction, so we are going to move to this one. This is related to if, then, else statement. Alright. So this is actually the very basics of the algorithms. Okay, the algorithms for decision logic structure. Okay, as I said, I need to make otherwise you will get confused. Put a note over here. Okay, so decision logic structure consists of one if. Statement bolehlah statement statements. Then the second one is case statement. Okay. Another one is case statements. Okay, if statement can be divided to single single selection. By selection and multi-selection. One more clear. Okay. You see in the algorithm, okay, there are keywords, okay, using if, then, else. So this is keywords, reserve word, okay, reserve word for if statements. Okay, but if it is a single selection, okay, the algorithms will contain only up until this point. So this is single selection. Okay, there's a condition, and then we have then. If this condition is true, okay, the compiler will execute these instructions. Instructions can be anything. Instruction can be equation, can be expression, can be input, can be output, can be another decision, can be a looping, can be a function, anything. Okay, instructions can be anything. Can be one instruction, it can be more than one instruction. Okay, if it is more than one instruction, then we have multiple line. For example, instruction 1, and then we have another instruction over here. Okay, can be more than one instruction. Okay. This instruction will only be executed if the condition is true. What is the condition? For example, if the condition is true, if x more than 1 is true, then the condition is true, it will execute. But if x more than 1 is false, so what it will do is, it will do nothing. Okay, it will do nothing. So this is only for if the condition is true. If the condition is false, it will do nothing. Okay, don't worry. We are going to look at the example after this. This is a general structure first. So this is single decision. So the flowchart for single selection. Okay, of course, when we are talking about decision, you should still remember decision involving a diamond symbol. Okay, so the keyword is if, and then we are going to have condition inside of it. Okay, condition. Okay. Condition. Okay. So if you still remember, for diamond symbol, okay, specifically if condition, if statement, so we must have two, kan? Arrow comes out from it. Okay, the first one is if the condition is true, kan? The second one if the condition is false. Okay. Okay, of course over here there will be arrow comes in, and then above here maybe input statement, calculation or anything that fit this condition over here. Okay, so over here if the condition is true, there is a statement over here. For example, a statement consists of equation equation we use this symbol rectangle ingat tak? And then if we have another instruction, so we have another rectangle or maybe inputs, output ke it can be anything input ke output ke, right? And then the arrow should be connected Okay, arrow over here. And this is for true. So this one need to be labeled. You need to label this one true. And this one suppose we change the color. True. So this is true. This if it is false. Okay. So what if it is a false condition? The condition is false. So it will go outside of the condition. This is the inside of the condition, and this is the inside of the condition. This is it. Inside of the condition. Outside of the condition is below and if. So and if is the end of the condition. So this arrow will go out. Go out. Go out. Then it will something like that. Will connect together. Okay, this one also will connected with this one. Okay, over here. Okay, so this is a single selection. Okay, by selection, still we have only one single condition. Okay, one diamond symbol. However, we say it as a by selection because we have else over here. Okay, else, this is same level. Okay, else no condition. That's why we only use one symbol only, because we have only one condition, which is this one. But this is for listing the false instruction or SN. It can be one or more than one. Okay, meaning that if single selection, there's no statements if it is false. But for by selection, if this is a false, there will be at least one statement. At least one statement. Calculation ke, input, output, anything. Or looping, or another decision over here. It can be any statement. Okay, at least one. You get it, class? So this is by selection. Okay. And lastly, we have multiselection. Okay, so multiselection involving more than one diamond symbol. Okay, where we put the symbol kan. Okay, normally, and the most effective way to put another condition to link with the first condition is by putting it in the false statement. In the false apa itu panggil ni? If the statement is false, if the condition is false, then we'll go to the next condition. Okay. Okay, so the algorithm is going to looks like this. Since we have two condition. Okay, so we must put if. Okay, only if you put if, you can put condition. You see, like this if condition. If there's only else, we cannot put any condition. So if it is a if, then you may put condition. Okay, so this become true lah. True. This is not here lah. Okay. Okay, so this become true lah, true instruction. So meaning that if it is true, what will happen? So if it is true, so what will happen? This have condition if lah. Else if, okay, and then condition Okay. So if it is true, so we execute at least one instruction over here. Okay. So you cannot leave multi-selection hanging with else if. All multi-selection must be ended with else. So this is what we say as the closure. The closure of the multi-selection, it must start with if and then ended with else. Over here, you may have more than one else if. Else if, else if, else if, else if, and the last one should be else. Okay, so same like the by selection. For else statement, we have apa kelas? What should we put over here? What should we put over here?
False instruction.
Right. False instruction false instructions. False false instruction meaning that it's supposed to be the false arrow over here. So if it is false, it must execute at least one instruction. Okay, instruction can be anything: input, output, calculation, decision, looping, anything. Okay, and then make sure your flowchart, if it is an algorithm, no problem. You can read it. For example, if this condition is true, then it will execute this instruction and then it will skip the rest of the statement and straight away go to an if. However, if this condition is false, it will skip these two instruction and check this condition. If this condition is false, it will skip this instruction and straight away go to executing the false instructions. Okay, this is clear. Okay, but for the flowchart, okay, if you put it like this, so wrong. So make sure everything in the end will be connected. So how do you want to connect everything? Make sure you connect it correctly. Okay, for example, this one over here, you cannot put it over here, so wrong. Okay, this is wrong. This is wrong. Okay, so make sure it is not connected with the rest of the instructions. Meaning that this instruction for this condition, you cannot connect it with the next condition instruction. Cannot Okay, so this you can put it over here. This you can put it over here. Okay, see, so it doesn't affected any instruction belong to other condition. Okay, you understand this class?
Yes, sir.
Yes.
Okay, so if you have more than two so just copy else if, and then we have else if, else if, else if, and so on. Okay, same goes over here. So this is the basic structure of if statement. Alright. So what should we put in the condition? Not everything we can put in the condition. So you must make sure that the condition must have at least one of this operator. At least one of this operator. Okay, either you use logical expression, okay, operator, or you use operator for relational operator. This one is not equal. This one, make sure you change it to double. Because equal is to give a value kan. Okay, if you still remember this is very important. This is also very important. Make sure you remember this till the end. If you put it like this, A equal to B, meaning that we want to give A the same value as B. If B is 1, automatically A will become 1 because we want to change the value of A to the value that is currently of B. Okay. But if you put it like this, A, B, meaning that we want to compare. Is A equal to B or not? So if A equal to B, then the answer, the value is going to be true lah. If A is not equal to B, so the answer, the outcome is going to be false. Okay. So in a short, we want the outcome for the condition. Okay, our condition over here, the outcome should be true or false only. The outcome cannot be numeric, cannot be alphabetic, a character, cannot be a string. Cannot. Okay, the outcome should be either true or false only. Okay, because we want to get this, kan? Either this instruction, if true, okay, if the outcome is true, we want to execute this. If it is false, we check with other condition. Okay, do you understand this? Okay, so the condition should be using this operator because this operator will give true or false output. Okay, so let's say if you use this operator kan, CAA plus B minus C. Do you get true or false value, guys? No, right? You will not get true or false value. Okay, but if you put it like this and you put it like this, A multiply C. Is it possible for you to get true or false value, class? Possible or not?
Yes.
Yes.
Yes, okay. At least one you apply this to your condition, then it become true or false value. Same goes if you put, for example, like this. So now it become true or false output value. And then you may put this inside of the condition. Okay, and it can be the combination. It can be the combination. Okay, for example, combination kan, meaning that this should be true and this should be true. If both is true, then the output, okay, the outcome of this condition is going to be true. So you may apply this combination. If you put or, meaning that if this is true, this is false, so the outcome of the condition is going to be true. Right? So this is what you can put in the condition. Okay, this is another example. Okay, let's look at okay, over here missing another one over here. So multi-selection. If this is single selection, this is by selection, so we have number Okay, number 3 betul lah. Number 3 it's not here lah. If else if okay, else if else if multi selection. And lastly we have the case ni. Later on we are going to look at the case instructions. Right, okay, now let's have a look at one simple example. So let's say if we have example over here, user input the value or there's a calculation whatever to give the student a value but for simple example, let's say student enter the total number of students. Okay, so if a students less than 65, so there will be equation over here. This is the equation. Okay, if a student, what if the value of student is 65? Is it true or false, class? The value of students is 65.
False.
Okay, correct. So if the value of students is 65, 65 is not less than 65 it is equal so it's going to be false. So what will happen for single? Okay, this is single statement. Single statement, it will go to false and go out of the condition. So this is the body of the condition. Go where? For example, over here, at the end, it will print student count. Simple print student count. And then n over here n don't forget to put n. Okay, so this is single selection. Okay, this is the algorithm. Okay, now if you want to make it by selection, so we must put another statement if it is false. So the statement shouldn't be the same otherwise what's the point to do decision decision should be the system should have different choice if it is the same, no need to put condition just straight away use sequential logic structure any condition you need you use the same calculation so no need for decision should have different instruction. Okay, so for example, if false, maybe the count will be different for example okay, so this now become by selection. And then for the algorithm, algorithm we have else else and the okay, so print student count. Where should I put this in the algorithm class? Where should I put this? Is it before an if or after an if?
After.
After So an if you look at from the flowchart, an if is over here. Okay, the point where true and false meet together. Okay, true or false meet together is an if. So if you see print is below the meeting point, so it should be over here lah. Meaning that doesn't matter your condition is true or false, at the end, every part will execute this instruction. Okay, true will execute this, false also will execute this. Okay, true execute this and skip this. Skip kan? If it is true, it will execute this, it skip this one and execute this. If it is false, this is false, it skip this one. Okay, it skip this instruction because this is for true condition and it will execute this and execute this. So this is example of biselection. Okay, next to make it, let's say this is a multiselection kan. Say this is multiselection, then we have more than one condition which is over here kan. If it is false, then we need to put another condition. Delete ni. Okay, another condition. For example, if this is false, okay, ni else lah. Else if student more than 65. So if it is true, and true for example, this is just example kan. This is a meaningless system example only for example. Okay, the count is going to be 2. And if it is false, this is true This is for true. This is for false. Okay. Okay, so make sure false also have statements okay, you cannot leave false hanging. Otherwise, else statement is not going to have any instruction. This is for else. Last is for the else. Okay. So let's say if it is false, we have this. Okay, so make sure it is connected at the end. It will connected with each other, but it will not affect with each other. For example, you cannot put the arrow from here to here. So what happens if you put like this? You understand, class? This arrow is wrong. Why is it wrong? Okay, for example, so we may check this. For example, user enter 100 over here. Okay, students value user enter 100. Okay, so if student less than 65 true, is it true?
No.
False. Okay. If student more than 65, true or false?
True.
Okay, true, it will execute this kan. So supposedly, it will execute this. But if you put the arrow like this, it will replace this execution with this. Which is wrong. It replace Okay, replace the value of student count that is supposed to be from this equation. Now from this equation. So wrong in terms of the flow. Okay, the flow is wrong. Okay, you make sure when you design your decision, the flow should be correct. In the end, all the conditions should be connected, but in a correct way lah. So how do you want to connect everything together but doesn't interfere with each other? For example, like this. Okay. And then this one over here. This one over here. So the flow is connected over here. So this is where the point of an if. An if. So this is an if over here. And below the an if, print student count kan? Print student count. So this is the flowchart for multi-selections. Okay, so for the algorithms, okay, the same lah. Okay, we have else if. Okay, so this is the condition so this is the condition. Condition should be put only if there is if. If no if, no condition Right, and last we have else kan. Else no if kan. So no condition lah. That's why we have only two kan over here. Two condition because we have only two if. If with condition Else no condition. Okay, so if you have another condition over here kan, let's say we have another condition. Another condition kan, whatever the condition is. Okay, let's say we have another one over here kan. So this is going to become, this will become else if lah. There will be another else if over here. Okay, 1, 2, 3. 1, 2, 3. Okay. Lastly, close by else. Else is for this over here we have false Okay. Any question class? Boleh? Any question? No?
No, sir.
No, sir.
Okay, clear Okay, this is by selection Okay, by selection. This is another example. Okay, don't put like this Okay. So formal algorithm should use formal operator lah. Okay. And okay ni. Okay. And next we are going to look at the case logic structure. This is number 4 kan. Okay, case logic structure is only can be used if the condition meaning that over here inside here the condition is involving integer or single character only. Single character. Okay, only. Okay, so if your condition is involving decimal number for example 1.1, so you cannot use case logic structure. If the condition, for example, example of the condition is A. Example lah, A equal to 1. So this is acceptable. So instead of, let's say you don't want to use if statement and you want to use case logic. So this is your condition. Then you may use case logic instead of if. Okay. It is the same. Okay, but you can choose either you want to use if or you want to use case logic. Okay. If this is the condition. If the condition is A equal to single character A. Z ke kan? Confused kan? So this also can be used for case logic structure. Condition kan? But if let's say the condition is A equal to Ali. Is it A equal to Ali? Ni comparison kan? We want to compare A. Is it similar with Ali or not kan? So this is not a single character. This is a string. So you cannot use this. You can only use if else statement. Okay, another way is numeric kan? Numeric if A equal to 3.5. Bukan A equal to, not A equal to 3.5 kan? You want to compare. Is it A similar with 3.5 or not? Compare kan? This value is to, this operator is to compare. So this is the floating point number. So you cannot use case logic structure. You can only use if statement. Okay, but the value is integer, then you may use case logic structure. So what's the difference between case logic structure and if normal if else statement kan? It doesn't matter if it is a multi-selection. For case logic structure, you have only a single decision, a single diamond symbol on it. And the arrows come out is only one. That's the difference. If let's say you have 5 conditions, you still use single diamond symbol. Okay, let's have a look at one example. Okay, let's say, okay, this is the example. Okay, insurance company has 4 different medical plans. Okay, the programmer has given each plan a code corresponding to the beginning initial of the company. Plan 1 F, plan 2 B, plan 3 K, plan 4 E. Okay. The company pays for all of plan 1. Okay, the individual has to pay for part of the others. Meaning that if user choose plan 1, meaning that it is free kan? The company pays everything. Okay, medical fees. But if user choose plan 2, so medical deduction is 4.65. Plan 3, this is the value. Plan 4, this is the value. Okay, so this one, I delete this. I delete this. Tak boleh. So I delete from here. I don't want you to get confused, so I delete this. Okay, so we have 4 plans. So what is the input class? What should be the input?
Plan 1, plan 2, plan 3, plan 4.
Plan 1, plan 2, plan 3, plan 4 kan? So what is the input? Give me one variable suitable for the input.
F, B, K, E.
Variable.
Oh, Mac code.
Medical code. Or you may use plan kan. For example plan kan. Or med code kan. Over here it use med code. Med code. Okay. Okay, let's say we follow the slides. Okay, med code. Okay, let's do the flow chart. Okay, start. Okay, this is start kan. And then we have input. Enter med code. So the value of med code, example of the value of med code class. Can I have 1 or 2 or 3 or 4 as a value? Is it correct or no?
No.
Wrong based on the requirement over here, cannot. The value should be F, B, K or E. Abjad character Z ke X ke can be the value kan. Okay. Alright. Next is next is the condition. Okay, so what is the condition? This is if you use normal if else. What should be the condition? Let me ask somebody Siapa saya tak pernah tanya lagi. Zamil, Muhammad Zamil. Muhammad Zamil?
Easy.
Okay, good. Okay, those who asked but didn't respond, consider absent. Okay, what should be the condition, Zamil? Apa Zamil?
Saya tak sure.
The first condition. What should be the first condition? Ni start
Plan 1 maybe.
If apa?
If plan 1.
Wrong. It should be related to med code. If
med code.
Okay, if med code. If med code apa? If med code
Saya tak tahu lah.
Dia tak tahu.
If med code.
Test ni nanti. Lagi 2 minggu lagi nak midterm test. Tak boleh? Tak apa. Okay, thank you. Nazim Syakir.
Yes, sir.
Okay, tolong kawan kamu ni. If make code,
Saya pun tak tahu, sir.
jangan cakap tak tahu. If make code, apa?
Sir, can I try?
Okay.
If met code is equal to F, if true, company pays for all.
Alright. Okay. So if make code equal to F, kan? F. The condition, kan? Okay. So if this is true, cik sangat. If this is true, what will happen?
Company pays.
What should I put in the statement over here?
Net deduction equal to 0.
Kan? Net deduction lah. So highlighted over here. This is a variable actually, kan? So this is actually being given to you, kan? Highlighted but during the exam, kan? So you need to find out what should be the possible variables. Okay. So net deduction equal to 0. Sikit lah. Ni. Alright. So this is if it is true, kan? This is true. Okay, don't forget to label your ni true false. Otherwise people will not know which one is true, which one is false. Alright. And then if it is false, what happen? If it is false,
If met code equals to 3.
apa dia? If kan?
If met code.
Dia else if ni. Else if
Yes.
else if make code equal to B, make deduction equal to .65. Okay, and then if make code equal to K, deduction equal to 7.85. Okay. Should I put another condition over here or should I stop? Do we need another one over here, class?
Sir, it make code equal to E.
Equal to E. Meaning,
Yes, sir.
this one, another one.
Yes, sir.
Okay, let's say we put another one. Equal to E. Deduction
5.5.
Okay. So this is for true kan? This is on for true. True lah. True. 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 This is if it is false. 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 Okay. So we have all the true condition. Okay, but for this one, if it is false, what happen?
Error.
If there's no condition for error, I delete it already kan? So what should be the value?
No false.
You cannot. If you didn't put any value, as I mentioned, if, else if should be ended with else. Okay, you cannot leave it hanging. It should be ended with else. So you need to give a value for the else. Okay. So if this is a condition, okay, maybe we must remove this. We remove, let's say if we have 4 condition, we remove one and make the last condition as else. Straight away, it will go to this one. Okay, so now we cover all the condition. But of course if user enter A kan, what will happen? What will happen? A.
Error.
Error.
Are you sure you will get error? If user enter A, let's test.
5.5.
If user enter A, okay, check this condition, false. This condition false. This condition false. Then we give value, make deduction equal to 5.5. Okay. So over here, before user enter the value, so you need to guide the user lah. You need to give the choice over here. So enter F, B, K or E only. Okay. Understand So you need to guide the user lah. You need to give choice over here lah. Before user enter make code. Okay. So now we have the complete if else statement. Not yet But over here, how to link everything together to get the end if to the end if point? Can I put it like this? Can I?
No.
No.
What happen if I put it like this?
Error.
No error. Error is when you cannot run your program. That is error. Print made deduction. Okay. Let's test Okay, let's say user enter F over here. Okay, user enter F, true kan? This is true. So we go over here, make deduction equal to 0. Correct, right?
Correct.
Yes.
Okay, and then user, the system will change the value to 4.65, change the value, and finally make deduction equal to what?
5.5.
5.5.
5.5. It is not error, but the output is wrong lah. Supposedly the output should be 0 kan? So when you design your flow like this, it will affect the correctness of the outputs lah. So make sure it is connected but in a correct way. And connected correctly lah. Benda. Sure it is connected. Okay, it should be connected with each other but in the correct manner. So you may put it like this. So now it is connected. So this is the point where everything connected. This is the and if point. And if. Okay? When you change this to algorithm, you may see this is the point of and if. And below the and if, we have print made deduction. Okay, this is N. Boleh kelas?
Boleh sir.
Boleh sir.
Okay, so when we want to compare this with case logic structure. Okay, case logic structure. Macam mana nak compare sebelah-sebelah So this is case logic structure. This is not complete. So we have input over here. Enter met code kan. Met code. This one. We edit later So we have print somewhere over here. Print met deduction kan. Okay. This is case logic structure. Okay, what we put in the diamond symbol is the variable that we use for the comparison. So in this case, we use met code kan. Okay, to compare the value of F, B, K and E. So we put met code inside of the diamond. The variable only. No other symbol, no other operator. Okay, we put the variable that we use for comparison. Okay, and then we put the condition in each of the parts. Okay, so this is if met code equal to F, what will happen? Okay, make deduction equal to 0. And this can be multiple instructions. Okay, for example, we have whatever over here. Let's say we have calculation A equal to B plus C. Kan? Or there will be another one over here, inputs, outputs. There's a if statement, there's a looping over here. Okay, there can be more than one instructions, not limited to only one instruction. Okay, understand this, right? Okay, so this is for B, this is for K, and we don't have this kan? We already removed this and we change to else, right? So this is the statement for else. We remove this. I don't want you to get confused with function. This one function, later on when we comes to the function topics, then we can discuss further. So now it become like this. This is print. Print. Tadi tu met deduction. Before exit. Before end. And exit we use only for function. This is function. No, we are not using function yet. So this is how it start. Complete. Okay, class. Any question?
No, sir.
Okay, please remember this is only applicable if the value that we compare over here either integer or single character only. Okay, if the value of math code is, for example, 1.2 kan, which is floating point number, you cannot use this. This is wrong. Okay, if the value is integer, you may use this. No problem. But this is of course it should be integer lah. The same lah. To, for example example 3. Okay, then you may use this. No problem Okay. So this is the algorithm. Okay, the algorithm start lah. This one is start. Or algorithm name Algorithm name is apa Math class okay. Of course we have the input and we have the input first and the math code, and then we go to the case of math code case of math code if math code equal to F, okay, we have this symbol over here. So let's say if you have multiple statement, just put it over here kan. Let's say yang tadi tu kan, A, B plus C, simple. So you can have more than one statement for single decision over here. And so on. So this, you already remove this. Become the else. So this is the else and numbers not 1 2 this is 1, this is 1, this is 2, this is 3, this is 4 5 6 line number line number, don't follow this one this is wrong okay. Lastly print last we print before the end of the algorithm. Print this is the algorithm. Okay class, any question? No?
Sir, for math code tu, kita tak payah letak double equal
No need.
Okay.
There. Alright, so this is another example. Okay, if you see use code to calculate on employees pay so you see clearly the condition involving single character H, P, C, S. So you may use this you may use the case structure okay, pay code equal to H. Okay, otherwise this one I don't want you to use this process error So otherwise the pay code is pay code salary. So the last statement we change to else. So this is else. Alright. Okay, similar thing. So this remove this. Remove this one replace with the S otherwise. Alright, simple example, and this is a comparison of algorithms. What missing over here, we have single apa ni tadi? Single selection. Okay, we have by selection. What we are missing over here is the multi-selection. If, else if, ended with else. Baiklah, saya sini. Ni kan, else if, and can be more than one else if. Else if, but in the end, it should be ended with else. This is multi-selection. Okay, comparison. So this is page structure. Right. This is in terms of flowchart. Again, missing more than one condition. Multi-selection missing over here. Okay. So once you know everything, next is the full problem solving process. So we start with the PAC first, and then ICIPO algorithm that's checking. Okay, let's have a look at the simple example. So you need to do a system to calculate pay. Calculate pay by hourly rate. Okay. But if you have overtime, which is over 40 hours, so the payment is 1.5 times the hourly rate. Okay. So the solution for PAC is like this. Okay. Okay, there are two ways to do this. Okay, this is how you can do it. Normally for sequential logic structure, if you still remember, the given data is about inputs. So this is the inputs. Okay, same for decision, we still put inputs over here. Okay, input hours and rate, for example. And over here, required result is the output. Okay, solution alternative also the same. Okay, define all given data, or you want to list down everything. Define hours, comma, rate as constant. Define hours, comma, rate as input value, and you put star. This is missing star. So we define this as an input, not a constant. But the difference is over here. For sequential logic structure, we only listing all the equation. If we have two equation, we put two equation over here. But for decision logic structure, you may put the decision involved in the design over here. Okay. You may put it like this, or you may just put a table. Let's say there's a table involved in the decision making. Example like this. Now this is another thing. Okay. This is, let's say, this is a table. So you may put the table inside of given data, not in the processing required. If you want to put it in processing required, you may put down if, let's say, this is another example. Let's say if amount purchase less than 100, so discount equal to 2%, for example. So you may put the if else statement over here. Or if you don't want, you may put the table related to the decision over here. This is decision lah. If amount of purchase more than 100 or n less than 500, I mean that this is in between 100 to 500. So discount equal to 5%. Okay, you may put it like this. The table of the decision over here. Or you may stick with this one. No table, but you list down all the decision in the processing required. Processing lah. Processing required ni. Okay, PAC Okay, clear PAC? Where you want to put the decision, either you put in the given data or in the processing required. Processing lah. PAC. Okay. For the IC, it doesn't shows any condition, any decision over here. Okay, don't show any decision for now. Later on when we move to function topics, then they probably have decision over here. So how we want to differentiate decision in normal statement and decision involving function, that one later on. But for now, let's stick to the no decision shows in the IC. No decision shows in IC. You clear class? So IC is normal. Normal like sequential logic structure. Boleh?
Boleh sir.
Okay. Okay. So clearly PAC we have a different over here compared with the sequential logic structure. IC no different. For IPO, of course, we show everything we show the details in the IPO. Okay, so this is actually the same like the algorithm. However, in terms of inputs, okay, we show the inputs, okay, the same like sequential logic structure. Okay, module, okay, input module, okay. This one supposed to be in calculation module. Okay. If you may put it detail lah. Calculate this one should be calculate as well. This is new line This is 4 6. Calculate 7. You put calculate. Put everything apa ni? 1, 2, 3, 4, 5. Supposed to be 5 Okay, calculate. Okay, and print. Okay, normal lah. Print output and payment control. Okay, so we shows the decision inside of IPO. And finally the algorithm lah. Algorithm normal lah. Algorithm This one supposed to be slightly to the right. It should be in line with if this is the same level. It's supposed to be the same level. Okay, this is slightly to the right because it belongs to if. This is the same level. This is slightly to the right. This is the same level. This is slightly to the right. Just stop kejap n lah. Right. Okay, so this is the algorithm. And finally the dash checking. Okay, first you need to set up the test data the inputs. And these are the inputs hours and rate, and also the outputs. Inputs, hours and rate. Okay, this is the input. Confused nanti. These are the inputs. This is the output. Okay, so let's say we have the input, the first set. So the dash checking, also similar with sequential logic structure. The only addition over here is this column. See, we have another column which is a condition. The rest is the same. The rest is the same. Okay, we must have all the listed variable in the algorithm. If you have 3 variable, put 3 in your dash checking table. Okay, we have line number. Okay, the line number of the algorithm, and we have the input output column over here. Okay, let's test this. Okay, so in line 1, nothing happened. Line 2 and line 3, we have hours and rate input. Okay, so line 2, hours input. Okay, this is input. Line 3, we have rate input. Okay, rate input. Okay, line 4, we check the condition, whether true or not. Okay, condition line 4, we have condition. Okay, so line 4, in the condition column, we check the value. Okay, so dash checking is all about value. So put the condition over here, but put the real value. So the condition is this hours more than 50, is it true or false? So hours value is 5 So hours value is 5. Okay, is more than 40, true or false? So the value is false. F lah. If the value is true, put true lah. So the value is false. What happened? It skipped this statement. Kan? The value is false. It skipped this statement. This is the statement if the value is true. So it skipped this statement. It go to the else lah and execute line number 7. So it skip this one. Line number 6, nothing happened. Line number 7, it execute the statement. So 5, 6 should be empty. That's why you see 5 and 6 is empty. In line 7, it execute the equation to calculate the pay. This one. Line number 7, execute instruction to calculate the pay. Okay. And line 8, there's empty over here because line 8 is an if. Nothing to display in the table. And line 9, display output. Okay, display pay. Line 9, pay equal to 150. Display pay. Okay, that's it. So this is if the condition is false. What if the data shows the condition is true? We use a second set data. The condition should be true. So what will happen? It will produce a different dash checking table. Okay, different dash checking table. You see the difference on here? This is line 7. This is in line 5. Okay, line 2 and 3 the same because we get the input sequentially and no decision to be made. But in line 4, now the condition is true. Earlier we test the data, the condition is false. But using the second sets of data, 42 is more than 40. It is true. So if it is true, if this is true, it execute line number 5. That's why you see over here, there's a statement in line number 5. Earlier, line number 5 is empty because this statement is false. Now, since it is true, we have the value over here equal to 1290. Okay. Alright. So this is nothing because we skip 6, 7 and 8 lah. Because we already get this value. Okay, we get this value. We skip else, we skip 7. This is nothing. That's why this is empty in the dash checking table. We didn't execute this. Empty 6, 7 and 8 is empty. So this is the output. Okay, class. Dash checking. Any question?
No, sir.
Okay, have a look at this again. Okay, retrace the flow. Okay, make sure you understand this. Okay, this will be asked during the assessment. Not sure which assessment, but there will be a question regarding the dash checking. Okay. Okay, another example that you may no, this is the flow chart. Okay, the flow chart compared to the algorithm this is missing what? What is missing in this flow chart?
The print output.
Print output Okay, supposedly we need to have the output over here. This is the end if the point where all the instruction map is end if. So below here we have print pay display pay ke print pay ke. Display pay over here before the end. Okay. Okay, have a look at this example. Try to do it by yourself. Okay, starting with the PAC, okay, IC, IPO, algorithm, dash check, and the flowchart. So next week we are going to discuss part 2. So now you know the what you need to do for the decision logic structure. So go back to your lab exercise and complete the task. Submit to me before Sunday midnight. Boleh kelas?
Boleh, sir.
Boleh.
Okay. Any question? No question? Okay, no
sir.
So fill in the attendance form and that's all for today. Thank you. Assalamualaikum.